Okay, this is just a quick follow-on video from the one on Pythagoras' theorem, and now we're going to advance this topic somewhat further by attempting some trigonometry. Now, trigonometry can be quite a daunting subject, and if it's a topic that you've not come across or haven't come across for some time, then I would very much recommend spending just an hour or two, shouldn't take any longer, just refamiliarizing yourself with this process. Again, there's a huge amount of material free online for this, so I won't be putting any up because there's more than enough out there. But we will cover the fundamentals here and everything that you will need if you are going to attempt this for your presentation assessment. This particularly pertains to the second phase, the takeoff phase of your long jump assessment. Anyway, first thing we need to do, if you aren't too familiar with this subject, is familiarise ourselves with our calculator functions, and we are going to be using three particular functions, and this is on my rather rubbish calculator that I have here on my PC. Yours will have it somewhere if it's on your phone. Most phones have scientific functions on them. You just have to turn the phone on the side and they will usually pop up. Likewise, if you've got a scientific calculator at home, then it will have these functions on there somewhere. The functions we are looking for are here: sine, cosine and tangent. Now, I won't be going through what exactly each of these functions means or the calculations that are being done when we select them to do our own calculations. If you wish to read up on that, you can, but for the sake of this video and for brevity, I won't be going into that. We will also need to know three more functions, and they are the inverted version of sine, cosine and tangent, so the opposite function. Remember, in the previous video we said how squaring a number and square rooting a number were essentially the opposite function of each other. So here we have the opposite function of the sine, cosine and tangent, and in order to get that, at least on my calculator here, I have to press this or click this button here, the invert button, and that has changed. Now you can see sine has got sine with this little superscript -1. Cosine has now got this little superscript -1, and so has tangent. And we refer to these as the arc sine, arc cosine and arc tangent. Again, I won't go into the calculations that are being done. If you want to read up on that, you can. It can be quite a heavy topic, but for now, we just need to know the six sines: the arc sine, arc cosine and arc tangent, and the regular sine, cosine and tangent. Okay, so let's carry on. Just a quick bit of background information. What are we using trigonometry for? Trigonometry is based on our six equations that we've just discussed, and we can use it to, much like Pythagoras' theorem, find out the length of an unknown side of a right-angled triangle. But in this instance, we don't need to know the length of the two other sides. We only need to know the length of one side and the size of one of the angles in the triangle, as long as it is not the right angle. And we can also use this to calculate one of the non-right angles, but in this instance you would need to know the length of two sides of the triangle. Again, it has to be a right-angled triangle. So really this is just an advancement on Pythagoras' theorem. We're just going to do some slightly more complex maths, but nothing too challenging. So we will use the exact same example we used in the Pythagoras' theorem video. In this case, our long jump example. We've got all the values on here that we've previously calculated in that video, so we know what the answers are, so that can be useful when you're just trying to figure out what you're doing and you're not too sure, if you're not too confident with it. It helps if you already know what the answer is, so you can practice some of the some of the calculations. Anyway, so here is our triangle. Now, for Pythagoras' theorem, we labelled each of the sides of the triangle A, B, and C. Now, for trigonometry, we're going to also label these sides of the triangle, but we're going to give them some slightly different names. And they are the hypotenuse, the opposite, and the adjacent. You can see where the functions on your calculator come from. So the hypotenuse is always the side that is opposite from the right angle. So on this particular triangle, that will be where C is. The opposite side is always opposite to the angle that you wish to calculate if you're calculating an angle. And that's primarily what we're going to be using trigonometry for here. We're just going to be using it to calculate angles. And the adjacent side is the remaining side. That's how I always think of it. So it's often described as being next to theta, and if it's not the hypotenuse, then it has to be the other side that's next to the angle of interest. So let's just label those. And there we are. Hypotenuse is always opposite the right angle, so that's basically going to take the same side as what we previously labelled as C. Opposite is opposite the angle of interest here, which is obviously in the bottom left-hand corner. We've abbreviated that to theta. And adjacent, I always just think of it as the other one. Okay. So we now need our equations, and we have three equations that we're going to start off with. They are sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. And as I said, we're going to use these equations to calculate theta. Now, in the case of your long jump example, you can think of this angle as the angle of takeoff. And that's very important in the long jump. If your angle of takeoff is too vertical, then you will just jump high but not very far. If it's horizontal, or too horizontal, you won't get enough height in order to jump far enough. You would perhaps think that around about 45 degrees would be the optimal angle of release for a long jumper, but surprisingly it's somewhere in the region of 60 degrees, and I have absolutely no idea why. Perhaps one of you can do some reading and tell me. Anyway, so we are going to calculate theta, as we said. So we once again have our three equations: sine of theta, cosine of theta, and tangent of theta. And we are going to include two of the pieces of information that we previously calculated. So we are going to have the opposite side representing the vertical ground reaction force. That was 300 newtons. And the adjacent side is going to be 500 newtons. That represents the horizontal ground reaction force, the anterior ground reaction force. Now we need to calculate theta, and we can use any of these three equations in order to do so, potentially, as long as we have the necessary information in terms of the length of the other sides of the triangle, or the length of the sides of the triangle in order to do that. So what I would say here is just pause this video and see if you can figure out which of these three equations you would use in order to calculate theta. You haven't got to do it, but just think to yourself, which would I use? Which of the three would I use based on the information that you have now been given? And we're just pretending that we don't know what the length of the hypotenuse is. Okay, so let's look at sine of theta. That requires us to know the length of the opposite, or in this case the side of the force, vertical ground reaction force, and the hypotenuse. Well, we don't know the hypotenuse. We only know the opposite side. That's 300 newtons. So we can't use sine of theta. If we look at cosine of theta, that requires us to know the adjacent side and the hypotenuse, so again we can't use that. So we are going to use the tangent of theta equation. So we have tangent of theta equals opposite over adjacent. We know that the opposite side, which represents the vertical ground reaction force, is 300 newtons. We know that the adjacent side is 500 newtons. So we can plug those numbers into our equation. So our equation now becomes tangent of theta equals 300 divided by 500. Now, this is where we do a small amount of jiggery-pokery, because tangent is a function, it's a calculation. And if we have tangent next to theta, that is essentially the equivalent of saying we will take this angle that we want to measure and find out its tangent. But we don't want to do that. We just want to know what the angle is. We don't want to know the tangent of the angle. So we need to make the angle here, theta, the subject of our equation. And in order to do that, we need to move tangent over to the other side of the equation. And when we move a number or a function over to the other side of an equation, it inverts. It becomes the opposite of what it was on the other side. So in this case, we take tangent of theta, move it over to the other side of the equation, and we are left with theta equals the arc tangent of 300 divided by 500. So let me talk you through what you need to do here. You will need to essentially just divide 300 by 500. So if you do that now on your calculator, you can pause here if you so wish. And you should have ended up with 0.6. Now, depending on your calculator that you use, this might vary, but if you type in 0.6, or if you still have that in your calculator, hit the invert button and then press the tangent button, you will get your answer, which here is, nearly clipped that off the video, 31 degrees. And I hope that makes sense. So it's really, whilst this might seem confusing, and this is going to be a very much a whistle-stop tour of trigonometry, it is just a case of pressing a button. You can get away with not knowing what your calculator is doing. We've just divided 300 by 500, hit arctan from that answer, and got this angle here, theta, in degrees, and that's 31 degrees. So we know in our example that we had of our long jump here that our athlete, when they took off, done so, and the angle of release was 31 degrees. So that's a fairly horizontal takeoff. That's not great. They need to be jumping higher at takeoff. Okay, so let's move on then to another example here. Okay, so here, instead of using the force data, we've used the acceleration data. Again, we've already calculated this, but it's not too big a deal. We're going to use, in case you haven't guessed, the sine of theta equals opposite over hypotenuse. And what I'd like you to do here, I'll just pause now, or you can pause now, is calculate the angle of theta again using the values that you have here. And you'll need to use the sine of theta over hypotenuse. Sine of theta equals opposite over hypotenuse, so just give that a go now. So what you should have done is divided 4 by 7.8 and then just used the arcsine function, in order to calculate the angle of release, which again will be 31 degrees. Okay, let's move on to another example. Here we are going to use a bit of trigonometry again, but this time, just for a change, we're going to calculate a side of a triangle, this unknown side, specifically the adjacent side. Again, we already know what the length of the adjacent side is, so you'll know if you've gotten wrong, basically. But using the information provided, have a go. I'll talk you through the answer, but have a go at working out the length of the adjacent side using your three equations that we've already discussed. You can pause here. Okay, so first and foremost, we need to decide which equation we're going to use. And hopefully you selected tangent of theta equals opposite over adjacent. From there, we need to plug in the values that we know. So in this instance, tangent doesn't have a number, it's just a function on your calculator. Theta is 31. Opposite is 4. And adjacent, we don't know. So we've plugged those values in here. Now again, what we need to do is rearrange the equation to make adjacent the focus of the equation. Because we know what the theta is. We know what theta is, it's 31. We know opposite is 4 meters per second squared, so we need to know adjacent. So we need to make that the subject of the equation. So again, a small amount of jiggery-pokery, and in this case, we are now going to rearrange the equation so that it is 4 divided by the tangent of 31 equals adjacent. So we know that 4 meters per second squared is 4 meters per second squared. We now type in 31 into our calculator and press the tangent function. This will give you 0.6, and if you divide 4 by 0.6, you will get the adjacent, which will be 6.7 meters per second squared. We already knew this, but again, it's just good practice. So there we go, a bit of a whistle-stop tour. As I said, do feel free to go through this video again and make use of any resources that you can find online. It's a very well-known subject, and there's lots of stuff out there, as I said, but you will need this specifically, as I say, for phase 2 of the long jump, the angle of release. And once you have that, you can move on to the next video, which is the perhaps most challenging one, which is projectile motion.